So we're looking at the page from the test preview, page 29, and I want to just explain what we do with these application questions, which we didn't have the chance to get to in class. The first one starts off with the rectangles, and it says, given the diagram below, polynomial 6x squared minus x minus 1 represents the area of rectangle ACDE. That's the entire rectangle. And you're asked to find out the polynomial that represents the area of ABGF. That's the small rectangle up at the top. Now, the topic is factoring, and it doesn't take a lot of thinking to realize that we're going to have to factor this trinomial 6x squared minus x minus 1. And you would do the factoring, but just to jump to the conclusion so that this video is not too long, it's going to be 2x and 3x, 1 and 1, and the larger of the two is going to be the negative 3x, and the 2x is going to be smaller, a positive. So now we assign this is going to be the base and the height. And looking at the dimensions and just, I have to accept either answer, but they're both going to come out the same way. But I'm going to assign the base as 3x plus 1 and the height as 2x minus 1. Putting those into the diagram, 3x plus 1, 2x minus 1, and they're just in units. It doesn't say centimeters or anything like that. Actually, let me write this a little bit nicer. And we're trying to figure out now an expression for the area of rectangle ABGF. Because we know the length of 3x plus 1 from E to D or from A to C, then we can find the length of AB by subtracting, and that's going to be 3x plus 1 minus 3. 3x minus 2, when you put that together. And when we're going for the length of FG, no, we're going to go vertical, the length of AF, that's going to be equal to 2x minus 1, again, minus 3, right? Because we're subtracting the portion that would be from E to F, equals 2x minus 4. And so what does that tell us? Well, the length of AB is 3x minus 2, and the length of AF is 2x minus 4. So we can now find an expression for the area of that rectangle. Area equals 3x minus 2 times 2x minus 4. Now, if it had only said find an expression, we would stop here, except that it asks for the polynomial, which means we're going to have to FOIL it out. And I'm going to do this in one shot where I do the inside and outside multiplications to get the middle term. And that's going to be 6x minus 12 and 4 is 16x plus 8. And that's going to be, squared for that 6x squared. And that will be units squared for that area of the rectangle ABGF. Moving on to the next question, B. The isosceles triangle below has the area of 1.5x squared minus 2x minus 2 centimeters. The base and height can be expressed as two binomials. Knowing that the perimeter is 11x minus 16 centimeters, what algebraic expression best represents the length of the slanted congruent sides of this triangle? So when we talk about the slanted congruent sides, we're talking about those two guys there. So this is a little bit confusing at first. I'm going to start off right away by factoring this trinomial, but I can't. Why not? Well, it's got a decimal in there. And so let's get into a little bit more about what's going on. The area of this triangle is going to be 1.5x squared minus 2x minus 2, and that is calculated as the base times the height. And here's where we're going to have a nice little situation because it's the base times the height divided by 2. So if I wanted to write down this what this is as just base times height, I would cross multiply and find out that 3x squared minus 4x minus 4, right, when I multiply that, is equal to base times height. And this trinomial does factor. It's a complex trinomial. You can figure that out for yourself, but it's 1x and 3x. and the values are going to be 2 and 2. The larger of the pairs is going to be the 6x, which is negative, and the smaller one is going to be the 2x, which is positive. And that's going to be base times height. Now, it doesn't matter which one we assign to which, but I think it's pretty obvious that the 3x plus 2 is going to be the longer of the two, and that would be the height. Notice it is not the side length, it's the height. So I'll call that the height. That's the vertical perpendicular from the base, which is x minus 2. Now, we have to figure out how to use the perimeter in this question. Perimeter is the length of all three sides. So that's going to be basically the base plus the side plus the side. Both those two sides are going to be equal. So I'm going to put in x plus 2, wrong, x minus 2 for the base, plus 2 times the side length. All right, so that's going to be 3 of the sides, and that's supposed to be equal to 11x minus 16. X minus 2 plus, well, you know what? I'm going to actually bring this over to the other side right away. So 2 times the side length is going to be equal to 11x minus 16. And then I'm going to subtract the x minus 2 onto the other side. So it's going to become negative x plus 2 on the other side. So double the side length, the two sides added together, is going to equal to 10x minus 14. Dividing both sides by 2, we're just using a little bit of logic here. If the two sides together are 10x minus 14, then one side must be equal to 5x minus 7. 5x minus 7, and you can double check the perimeter on this. When we put the three sides together, equal 11x minus 16. Don't forget your units, it's in centimeters. And little side note here, you should put it in brackets to show that the centimeters represents the 5x and the 7. Hopefully that makes a little bit of sense to you. Yeah, it's not completely easy, but it's a matter of just using the factoring and applying it to the question. Question C is, I think, a little bit more straightforward, except that there's a little red herring here, which might get you a little bit confused. It says, show that the area of the shaded region is equal to 3 times x plus 12 times x minus 8. The shaded region, of course, is the ABCD or ABDC minus the white rectangle. Now, the first inclination you might have is to try and factor that trinomial. Yes, I fell into that trap. It actually doesn't factor. And if it did, it probably would get you the wrong answer for the rest of what we have to do here. What we have to do is find an expression for the shaded region, but we're going to do it not from the statement that's given, but from the expressions that we have in the picture. Now, the area of ABCD, which should actually be named ABDC, the area of rectangle ABCD is 4x squared plus 18x minus 279. That's the rectangle. And then we have to subtract the square, and that square is the product of x plus 3 times x plus 3. Just for symmetry's sake, we'll put them all in brackets like that. And this is the area of the shaded part. And we're going to try and simplify this and see if we can turn that into the expression you see over there. Don't factor. We're going to expand, and we're going to put the like terms together. So 4x squared plus 18x minus 279 minus, and then I'm going to do this first as x squared plus 3x is 6x plus 9, and then subtract each of those terms individually. Minus x squared minus 6x minus 9, leaving us with 4x squared plus 12x, right, the 18x minus the 6x, minus 279 minus 9, they're both negatives, would be 288. I made a mistake. 4x squared minus 1x squared is 3x squared. That's more like it. And how do I recognize that mistake? Well, I know that it's going to have to be matching what we see up there on the top. So to factor this, first I'm going to remove the common factor 3. And 288 divided by 3 is 96. You probably don't know the factors of 96, but the one that's going to work for us here is 8 times 12. So it's x squared. Let me fix that. It's x plus 12 and x minus 8 for my two factors, just like you see up on the top there. It kind of helps knowing what the answer is that we're looking for, and that's going to be in square centimeters. Letter D. Now this one looks scary because it's got a circle in it. I don't know why that's put in there. It's just to scare you, I think, because we're not using pi r squared or anything sort of formula like this. It asks you, the circle with an area of x squared minus 3x, so the area is already given, is inscribed, which means it's put right inside the rectangle. The base of the rectangle is 3x plus 4, so that's the top or the bottom, and the height of it is x plus 5 on the left or on the right. And these guys are both in centimeters. Show that the area of the shaded region is equal to 2 times x plus 1 times x plus 10. So this is just another case of the area of the shaded, which is going to be equal to, you're going to take the area of the rectangle and you're going to subtract the circle. So the area of the rectangle can be calculated as 3x plus 4 times x plus 5. And the area of the circle is going to be just given x squared minus 3x. So just like we did in the previous question, we're going to expand this out and turn it into a polynomial that we're going to factor. So multiplying this out, and it's kind of weird, we haven't done the FOIL too often, and remember that this is what factoring has been the reverse of this. So 3x squared, 15x, 4x, and 20. You probably could have put the 15x and 4x together in your head, minus x squared plus 3x. And then putting all the pieces together, 3x squared minus x squared is 2x squared. 15x plus 4x, 19x plus 3 is 22x. And the 20, no partner for that one. Factor out the 2. And then we can factor that trinomial equals 2 bracket x plus 11, x plus 1. Whoops, not x plus 11, silly. X plus 10, x plus 1. Just like we wanted to show centimeters squared. Now, you may have seen on Studio, hopefully you looked there, I said to cancel question E to leave it out. This question is unnecessarily confusing, difficult. It actually comes, unfortunately, from a secondary 4 provincial exam. So don't worry about that. We're going to stop right there. And yes, you can expect one of these problems, one of these types of problems on your test tomorrow, where you have to work with area and do some sort of factoring to simplify it into the proper format. Good luck studying.